students, so today we are continuing our discussion on electromagnetic induction. So in electromagnetic induction we have studied how electric flux, change in electric flux. Okay, what is electric flux, then change in electric flux, how it causes induced EMF, okay, why induced EMF is formed, and if it is a closed circuit then there will be induced current, and what will be the direction of induced EMF, induced current, all that. Okay, and that we have studied under Lenz's law. Okay, then after that if a coil is made to rotate, then how it is going to induce EMF, the fundamental of alternating current, all those things we have already seen. Okay, so here what is electric flux? Electric flux is magnetic field vector dot area vector, or we can say BA cos theta. Okay, this we have studied. Then EMF induced in the coil is equal to what? Minus d phi by dt. So what is this negative? Negative indicates, okay, change in flux will cause this EMF. This negative sign indicates this induced EMF will try to oppose that change. Okay, so regarding this direction of EMF, direction of current, we have studied in Lenz's law. Okay, Lenz's law. Okay, we have discussed the direction. Okay, direction of induced EMF, associated with induced EMF, current, the direction of magnetic field, all those things we have seen. Then this induced EMF, suppose if we take its magnitude, this is d phi by dt, or we could say d by dt of BA. Okay, if this theta is 0 degree, it is BA, 90 degree, that will become 0. Then again if it is rotating, theta will change, so d by dt of BA. Suppose if the flux, if we are trying to find the induced EMF instantaneous value, then what we do? D by dt of the magnetic flux. Okay, or otherwise suppose if we are trying to find E average, then what we do? Instead of writing like this, we do delta phi divided by delta t. Okay, so in this, suppose if magnetic field changes, that also will cause induced EMF. If area change, that also will cause induced EMF, or otherwise induced EMF is equal to d by dt of BA cos theta. Suppose if these two things are constant, BA d by dt of cos omega t, theta is what? Omega t. So this will cause the induced EMF is equal to BA omega sin omega t. Suppose if we put a negative here, this negative also will come, this will become E is equal to BA omega sin omega t. If there are n number of turns, E is equal to what? NBA omega sin omega t, or we say this is the maximum EMF possible, E naught sin omega t. This is nothing but alternating voltage, alternating EMF. So any change, if magnetic field changes, or if area changes, or if the orientation of the loop. Orientation means if it is like this, then theta will be 0, theta will be 90, theta will be 180. Likewise, if it rotates also, this will change. That is what we have written here. So all these things we have studied. Along with that, we have studied about the if a moving road, if a road, if it moves with a velocity, if its length is L, then if this is magnetic field, then the motional EMF E is equal to what? In general we say BLV, but instead of that we should say scalar triple product V cross B dot L vector. Okay, so what is this? Scalar triple product. So whatever be the direction of V cross B, so the result of V cross B, this is cross product, the result of cross product will be a vector. So V cross B will give as a vector, it will have a direction. So that vector dot L vector. So the direction of L vector we can take in this way, or sometime we can take in this way also. Okay, L vector, just in moving charges and magnetism, we used to take the direction of L as the direction of current, the current carrying conductor, and whatever be the direction of current, that we will take the direction of L. It is not like that here. Okay, so here while doing problems we will discuss all that. V cross B will be a vector, that vector we will have to do dot product with the L vector. So V cross B will give a direction that will induce the direction of EMF. With respect to that, we will take the direction of L vector. Okay, so even in other way also, even if we take magnitude wise, there is no mistake. Okay, we can take that also, but you should take positive sign, that's all. Okay, so this is scalar triple product. We have done some problems also in the previous session. Now again we will continue from here, we will continue doing problems on this. Okay, see this question, children. Here there is a conductor which is moving in this direction. Okay, so this is the conductor which is moving in this direction. Okay, so what is the induced EMF? So here induced EMF E is equal to V cross B, V vector cross B vector dot L vector. Okay, so how to find the cross product of V cross B? I mean the direction. So this one is the velocity vector, and these fingers are the magnetic field vector. So this is the direction of magnetic field vector. Since the velocity is in this direction, this is going to be, this palm is going to be the direction of what? Direction of V cross B. So this is going to be the direction of what? V cross B vector. And obviously, since this is cross product, the result of this one will be perpendicular to both V vector, and it is going to be perpendicular to B vector, magnetic field vector. So anyway, magnetic field vector is into the plane of the board. So this is 90 degree, fine. This is V, so this is again what? 90 degree. So I can mark here, this is 90 degree. So 90 degree plus 30 degree is what? 120 degree. So obviously this angle is going to be how much? 60 degree. Now this 60 degree is the angle between L vector and V cross B vector. So E is equal to VB vector L vector dot L vector. So this is equal to VB, magnitude of VB, magnitude of L into what? Cos 60. So E is equal to cos 60 is, we can say, BVL divided by 2. This is 1 by 2. I'm sorry, root 3 by 2. Cos 60 is, okay, 1 by 2. Cos 60 is 1 by 2. So the answer is BVL by 2. Clear? Take another question, children. So here you can pause the screen and try for yourself. Okay, try for yourself, then verify the answer. Okay, so E is equal to V cross B dot L vector. So what is V cross B? So this is the direction of B, this is the direction of V. So this is going to be the direction of what? That is going to be the direction of, this is going to be the direction of VB vector. Okay, this is going to be the direction of VB vector. Okay, now what is the angle? This is 90 degree. This VB will be perpendicular to V, and that will be perpendicular to B also. Now suppose if we write like this, if we draw like this, then it makes what angle with L vector? This VB makes what angle with L vector? So here this is 45 degree. Then what about this? This is also what? 45 degree. Correct or what? So it makes 45 degree with the L vector also. So this is going to be magnitude of VB, magnitude of L, and this is cos 45. So BVL by root 2. Okay, So now when you take the direction of induced EMF, how to take? So here V cross B, V, this is V, so this is going to be the direction of what? VB. So since this is going to be the direction, we can take the EMF in this way. Okay, since EMF is not a vector, but current or the polarity is there, so that polarity can be taken in this way. Okay, so this is the direction of magnetic field, this is the direction of velocity, you are taking like this. So this is going to be the direction of VB, so we can take the EMF in this direction. Okay, clear? Take the next question, children. So here magnetic field is inside, magnetic field is inside. So the magnetic field is inside, the direction of velocity is this. So this will be the direction of V cross B. E is equal to V cross B dot L vector. So V cross B will be in this direction, this direction. So here perpendicular to V, perpendicular to B. This is going to be the direction of VB vector. Now what direction whether this makes with the L vector? So which angle to take? Either we can take in this way or we can take in this way. Okay, it will not create any problem, but for our easiness what we will do, see, this is the direction of magnetic field and this is the direction of velocity, we are taking like this. So consider the EMF in this direction. Okay, see, this is the direction of magnetic field, this is velocity, so this is how in upper direction VB vector will act. So in the upper direction we can take the EMF polarity. Okay, right. Now this is going to be 90 degree, this is going to be 90 degree. If this is 37, this is going to be 53 degree. So the magnitude of VB, magnitude of L and cos 53. So BVL, how to take cos 53? You know how to draw this triangle. So this is 37, 53, 90, 3, 4, 5. So cos 53 means this is going to be 3 by 5. 3 by 5. So 3 by 5 BVL. This is the answer for this question. Next question, children. So here find the induced EMF. They have given a semicircle, okay, a semicircular conductor, and this semicircular conductor is moving in this direction. So here again the same concept, E is equal to what? V cross B dot L vector. Okay, V cross B dot L vector. So B is inside, V is acting in this direction. See, B is inside, V is acting right hand palm rule. B is inside, V is acting in this direction. So this is the direction of what? VB vector. So I am marking the direction of EMF also in this direction. Okay, EMF doesn't have direction but polarity is there. That polarity I am taking from what? V cross B. Now so this is the direction of what? V vector, VB. Okay, this is the direction of what? VB vector. Now what is the direction of L vector? Okay, what is L vector? Okay, so here E is equal to magnitude of VB, and this L we should take like a 2R. That is between this point and this point, this L we should take as displacement. This is vector. This is vector. So we need not take the distance. We should take the displacement. Okay, we should take the displacement. So that displacement is nothing but between these 2 points. So okay, and I am considering the direction of L vector as this. So this is going to be cos 0. So EMF is equal to what? 2 BVR. 2 BVR. Okay, so this is the answer. If you take pi r, that option also will be here. This is wrong. Take the next question. Find the induced EMF. Okay, so here two conductors connected here, L, and the angle between these L is given as theta. Okay, and this is moving in this direction. Okay, now what is the induced EMF? What is the induced EMF? Okay, pause the screen and do yourself. Pause the screen and do yourself. Okay, so induced EMF is equal to V cross B dot L vector, right? So this is the direction of magnetic field and this is the direction of velocity. This is the direction of velocity, this is the direction of magnetic field. So direction of VB, direction of V cross B will be in the upward direction. So I am going to consider the polarity of EMF as in this direction. Okay, V cross B, V cross B, upward direction. So I am putting the polarity like that. Now this is VB. Okay, this is VB vector. Now what is L? So L will be between these two terminals. This must be the length, displacement. So if this is L, then this is going to be theta by 2 and this is also what? Theta by 2. We could resolve this as this is going to be L sine theta by 2 and this is also what? L sine theta by 2. So this total length of AB is going to be what? 2L sine theta by 2. 2L sine theta by 2, that we can put here. So VB vector dot what? 2L sine theta by 2 vector. Okay, so direction already we have taken, so we could write like this is going to be 2 BVL sine theta by 2. This is the answer. Clear? 2 BVL sine theta by 2. So this is another question. Find the induced EMF across the terminal A and B. Okay, so here this theta is given. This theta is given theta. Okay, this angle is given as theta. Fine. So what is the induced EMF across the terminal A and B? Okay, pause the screen and try yourself. Okay, all the answers, we don't have given any numerical values. So BVL sin theta, BVL cos theta, BVL by 2 sin theta by 2, something like that. Okay, so try it. Fine. So as usual, E is equal to V cross B dot L vector. So this is the direction of magnetic field, this is the direction of velocity. Palm will show the direction of what? Perpendicular to this line we have the direction of what? V cross B vector. Okay, this is the direction of V cross B vector. So this angle is going to be what? 90 degree. So if this is the direction of velocity, sorry, this is the direction of velocity, this is the direction of magnetic field. If this is how the direction of V cross B, then what we do? We can take the EMF like this. Clear? This is the direction, we will take the EMF polarity like this. Okay, so then what should we find? We need this angle. We need this angle. So what is this angle? Total is 180 degree. Total is 180 degree. So this angle is going to be 180 degree minus this 90 minus this theta. So this is going to be how much? 90 minus theta, this angle, right? So we can write this is VB vector magnitude L, then cos 90 minus theta. So BVL cos 90 minus theta is what? Sin theta. So this is 90, 0. 90 minus theta means here all. So all are positive here. So EMF is nothing but BVL sin theta. Okay, BVL sin theta. So it is very important to understand how it is to be taken. Next question, students. So this question, they are given a loop. Okay, so this they have asked in JE mains. Okay, so they have given a loop. The dimension of loop is also given. Okay, dimension of loop is also given. Text is there. I have the text I have given like readings. Okay, I have given like measurements I have given. So question text I am not writing. Okay, they have given the details. So loop is there. Each side of loop is 5 centimeter, and this loop has got resistance also 1.7 ohm. And this whole system is moving with the velocity 1 meter per second, and this is connected to a network like this. Magnetic field direction is given. Okay, coming out 1 Tesla. Okay, right now what is the current in the network? How much is the current flowing in this? Okay, that is the question. So pause the screen. You have current, electricity basics, that also can be applied here. Then how to take the EMF, all these things you know. So try to answer this. Clear? Fine. So how to find EMF? First we need to find EMF V cross B dot L. Okay, this is the fundamental. Now if velocity is moving in that direction, magnetic field is in this direction, fine. So this will give a result. And already we have studied in the previous sessions, like if velocity and magnetic field, if they are in the same direction, okay, or if they are parallel or anti-parallel, what will happen? There won't be any EMF will not be induced. Okay, so V cross B, so V and B must be either 90 degree or some other angle, should not be 0 degree. That is one condition. So velocity is this, magnetic field is in this direction, so fine, that is good. Now this L vector for this one, okay, and this one, okay, so this L vector is in parallel with the velocity vector. Okay, so due to this segment and due to this segment, okay, there won't be any EMF. Why? Because just take the direction of V cross B. Okay, so this is direction of magnetic field, this is the direction of velocity. So direction of EMF we are expecting in this direction. So if this is the direction, then let us, I am just assuming that I am just giving that this is the direction of V cross B. This is the direction of V cross B. What about this segment and this segment? The problem is they are at 90 degree with this one. So this and this will not help us in giving a EMF. Okay, only this segment will give us EMF. Anyway, this one is opening to the other area, so this segment will give us the EMF. That is the fundamental which we need to understand. And here just take the EMF, only this part is inside the magnetic field. Okay, this, remove this. Okay, so this L will give us the EMF. Okay, so right, EMF is equal to what then? EMF is equal to V is 1, B is 1 Tesla into L is going to be 5 centimeters. So 5 into 10 raised to minus 2. So E is equal to 5 into 10 raised to minus 2 volt. Okay, so this L and this magnetic field direction, okay, they are 0 degree. So BVL we will be getting theta is equal to what here? This theta is equal to what? 0. Fine. Right. Now 5 into 10 raised to minus 2 volt will be there. Now what we need to understand, see 5 into 10 raised to minus 2 volt. Okay, this is how. Now this loop resistance is given as 1.7 ohm. Just like internal resistance, we will mark this as 1.7 ohm. Then what about this? These two terminals. Okay, these two terminals, if we take, this is nothing but Wheatstone's bridge. Correct or what? 2 by 1 is equal to 2 by 1. It is balanced. So this resistor we need not consider. So this is series combination 4 ohm and this is also series combination 2 ohm. So this resistance is how much? This is actually R equivalent of this network is 4 into 2 divided by 4 plus 2. This is 8 by 6. What will come? 1.3 will come somewhere around. 1.3 ohm will come. So we can mark this resistance as 1.3 ohm. Correct. So current is equal to how much? 5 into 10 raised to minus 2 divided by this 1.7 plus 1.3. Correct or what? 1.7 into 1.7 plus 1.3. Clear? This velocity in question they have given like 1 centimeter per second. Okay, 1 centimeter per second. So this is going to be 1 into 10 raised to minus 2 into 2. So this will become 10 raised to minus 4. Okay, so this is 10 raised to minus 4. So this is going to be how much? This is 3. 5 by 3. 5 by 3 will be how much? This is 5 by 3. 5 by 3 means around 1.6 into 10 raised to 1.6 into 10 raised to minus 4 will come. So that we can 1.66 into 10 raised to minus 4 will come. That we can approximate to option B. Okay, clear? That is the answer. See students, so here in this a conducting rod is moving with a velocity v along two conductors, magnetic field B. So its direction we can see cross means it is going inside. Okay, going inside. So here if it is going inside and if the velocity is in this direction, we know that we can consider the EMF in this direction. Okay, so first point, okay, first point, E is equal to what? V cross B dot L vector. So V and B, they are at 90 degree. So we can say VB. And what will be the direction of V cross B? This is V. And if it is going inside, this is how. This will be the direction of what? This will be the direction of VB vector. VB vector. So it is coinciding with the direction of L. So here if we write cos theta, that will be what? Cos 0. So VBL, or we can say E is equal to what? BLV. So this is the EMF here. Okay, already we have seen many cases. Next thing is, suppose if we need to find current. Okay, if we need to find current, I is equal to what? E by R equivalent. So here if this conductor is connected to a resistance capital R, and if this rod has a resistance small r, then we can write IE is equal to EMF is what? BLV divided by R plus R. Fine. Now suppose if a current is moving like this, so in this case what will happen? A current will move in this direction, okay, then current will move in this direction. So if current moves in a current carrying conductor, or current moves in a conductor, we say current carrying conductor, that will experience a force. What is force in a current carrying conductor? Okay, force in current carrying conductor is what? I into L vector cross B vector. So if we consider current carrying conductor, this L vector has got a direction now. This is the direction of L, and the direction of B is what? Inside. So this is the direction of current. This is the direction of magnetic field. Magnetic field is going inside, and current direction is this. So I can say that direction of L is what? Upside. So can I write in this way? F is equal to I into LJ. Okay, LJ, L vector is LJ cross what is the direction of B? Okay, B is K. B is K. Likewise we can draw. Suppose if outwards, if we are taking K, then inward, that is inside, this is going to be minus K. Okay, so whatever it may be, even though if we take here minus K or plus K, let us see that. Now if we consider this L in this direction, okay, in this direction, and the direction of magnetic field is this, then the direction of force will be towards this direction, this palm direction. So I can mark the magnetic force in this direction. So this is minus. So let us consider this as K, this is minus K. So this is going to be minus BK. So the force direction is going to be what? Minus I. So this is the direction of magnetic force on this conductor. Now we are claiming that this conductor is moving with the velocity v. So that is what this sentence, the force required to move the rod, with the velocity v must be what? This must be equal to this force. So that we will write the force F is equal to what? I L cross B. So that is nothing but all are perpendicular. So we can write ILB. So here we have found already BLV by R plus R is the current. So the force is equal to what? BLV divided by R plus R into what? BLV. LV. Clear? So from this we got force is equal to what? B square L square V divided by R plus R. Clear? So if we remember this formula, fine, or otherwise we need to calculate from here. Okay, just like E is equal to BLV, force is equal to what? F B square L square V divided by R plus R. Note it down. Okay, so external force must be there. What we are finding out is this much magnetic force is there. So this must be the external force for constant velocity motion. In order to get a constant velocity, we have to apply same amount of force, then only it will be moving with the constant velocity. So this external force external force must be equal to Fm. F external must be equal to Fm for constant velocity. For this rod to move with the constant velocity, we have to apply an external force equal to this magnetic force. So that is what? Magnetic force is what? B square L square V by R plus R, or simply BIL, or I into L cross B. Clear? So please note it down. Clear? Now next thing is power input. Power input is nothing but F dot V. This is moving with a constant velocity V, so power is equal to F dot V. So what is the force? Input force, the force which we are applying, that we have found here, same magnitude, B square L square V divided by R plus R, here this dot V. Both the forces, force as well as velocity, both are in same direction, so we can directly multiply. So power input is equal to what? B square L square V square divided by R plus R. This is the power input. Clear? Now what about power output? Suppose if we consider this EMF here, R, external resistance capital R, and this is R, this is E. So I will be moving here. So what is the power output? Power output is nothing but the power that is dissipated in the resistors. So here power in this resistance R is what? I is equal to what? BLV divided by R, that is the EMF. BLV divided by R, and power across capital R is what? BLV divided by capital R. Correct or what? Okay, sorry, here power, so I square R, B square L square V square by R. So power output is equal to P across R plus P across R. If we take, then we will have to add this. We will be getting what? B square L square V square. If we take out, okay, B square L square V square divided by R plus R we will be getting. So same, whatever be the power input, same power output we will be getting. Okay, clear? So this is suppose if a rod is moving with velocity V, EMF will be generated. If we have such setup, magnetic field, perpendicular magnetic field, perpendicular velocity, a rod of length L, then there will be an EMF BLV by R, or BLV by R plus R will be the current. Power is equal to what? Either I square R, or we can take F dot V. So power will be B square L square V square divided by R plus R. Okay, fine. So power input, power output both are same if there is no other loss of energy. Okay, Fine. So power output, suppose if we connect any lamp, bulb or something here, okay, this movement of this rod, mechanical movement of this rod will be converted into electrical energy and this will glow. Okay, many cases can be asked. Clear? Note it down. Okay, so here this is another question. Force needed to move this rod. Okay, here this rod is moving with a constant velocity 2 meter per second. Resistance is 3 ohm is connected here. This rod length is 50 centimeter. Magnetic field which is moving inside, cross, okay, 0.15 Tesla. Okay, these many details are given. Force needed to move this rod. Okay, so already we have seen, okay, if a current carrying conductor is moving in this direction, okay, so EMF will be what? EMF generated along this will be what? V cross B dot L vector. Since all of them are mutually perpendicular, we can directly write BVL. Okay, all of them are mutually perpendicular. V cross B will be VB because the angle between them is 90 degree. This vector will be parallel to this one, so the theta is 0, so BVL. Okay, then what will be the direction of EMF here? Means I mean the polarity. If this is moving in this direction, magnetic field is going inside, then obviously an EMF will be induced in this direction, so current will be flowing. Okay, current will be flowing. If current is moving in this direction, then what will be the force? So here if we want, we can find EMF 0.15 Tesla is the magnetic field, 0.15 Tesla. Okay, 0.15 Tesla into the velocity is 2 and its length is how much? 50 centimeters, so 50 by 100. Okay, so this could be 15 by 100. So in this way we can find the EMF. Okay, so this is going to be 15 or 0.15 volt. 0.15 volt will be the EMF. Okay, now if we need to find the current, I is equal to what? E by R. There is no resistance mentioned about this rod except this external resistance. So this is going to be 15 by 100 into this resistance is what? 3. Let us put here 15 by 100 into 3. So this is going to be what? 5. So 5 by 100 or 5 into 10 raised to minus 2 ampere. Okay, right. So this is the current. So when this current is flowing like this, okay, force will be what? A force, magnetic force will be acting. F is equal to what? I into L cross B. L vector cross B vector. So L vector is in this direction, okay, and B vector is in this direction. So force will be, magnetic force will be acting in this direction. Okay, so what will be that force? This force, magnetic force, is equal to ILB. I already we have found, this is 5 by 100. L cross B will be LB sin theta. Theta is 90 degree. So LB, L is what? 50 by 100 into B is what? 15 by 100 again. Yeah. So this is going to be the force. Okay. 2. So 5 into 15. So 75. 75 divided by 2. So this is into 10 raised to minus 4. So 37.5. 37.25. Okay, 37.25 into 10 raised to minus 4. That is the answer. This is the force. Okay, or we could write magnetic force is going to be 3.725 into 10 raised to minus 3 Newton. this much force will be acting in this direction. Okay, so this much force will be acting in this direction. So force needed to move this rod, that is, we should apply an external force equal to this one, then only this will move with the constant velocity. That one is nothing but 3.7 into 10 raised to minus 3 Newton. This is the answer for this question. Take this question, students. So here a capacitor is connected, its value is 10 microfarad. A rod of length 1 meter, the length of this rod is 1 meter. It is moving with a velocity 2 meter per second, constant velocity 2 meter per second. Magnetic field is given 4 Tesla. Now these are the options given. Okay, what will be the charge on the capacitor? Okay, right. So how to find? So if the rod is moving, magnetic field is in this direction, okay, going inside. Velocity of the rod is in this direction. So obviously this will be the direction of EMF, I mean polarity. Okay, this is how. And here the capacitor will come. So what will be this? BLV, because all of them are mutually perpendicular. Magnetic field, length of the rod, velocity, all are mutually perpendicular. 4 Tesla into 1 into velocity 2, we are going to get 8 volt. 8 volt. So this is actually 8 volt. So Q is equal to CV. So 10 microfarad into 8 is actually 80 coulomb. 80 microcoulomb will be the charge going. Since this is moving in this direction, here this is A, this is B. Current is moving in this direction, so here it is going to be plus, here it is going to be negatively charged. So QA is going to be 80 microcoulomb and QB is going to be minus 80 microcoulomb. Clear? So here this is another question. Data I have given in this figure, 2 parallel rails, okay, or conductor, through that a rod is moving. Okay, one side a resistance is connected like this. Okay, suppose if the rail is moving like this, the resistance is connected like this. That's it. At a time t is equal to 0, velocity is 0. Okay, and at a time t, at any time t, velocity is v. That is, this time the velocity is not constant, and a force is applied which is a constant force. So what we must understand is, at a time t is equal to 0, velocity was 0, then because of this force it started moving. What we need to understand, find, is terminal velocity of the rod. Okay, terminal velocity of the rod. What is terminal velocity? Generally terminal velocity we study in fluid mechanics. Nothing but if many forces are acting on a body, and if the velocity depends on the force, after some time when net force becomes 0, the body will start moving with the constant velocity. That velocity is what is terminal velocity. Here also the same concept. So now try to solve this problem. Pause the screen and try to solve this problem. These are the options. Okay, try in your way. Right, students. So let me solve. So here the magnetic field direction is this. Because of this force, it starts moving in this direction. So magnetic field is outside, and this part rod is moving in this direction. So this will be the polarity of EMF. This will be the polarity of EMF. Sorry. This will be the polarity of EMF. Clear? Fine. So current will be moving in this direction. Now this resistance is kept like this. like this. So even if it is like this, or even if it is like this, it doesn't matter, it will not affect us. So what I am going to do is, I will be drawing this, I will be just drawing this in a normal form, because it is not going to make any difference here. Okay, so this is the resistance. Fine. Now if the current is moving like this, if the magnetic field is in outward direction, and if the current is moving like this, then the magnetic force is going to act in this direction. This is the magnetic force. So what is the magnetic force? Magnetic force Fm is equal to what? B square L square V. This is variable, agree. B square L square V divided by the resistance R. This is the magnetic force. So this is a constant force and this is the magnetic force. So when velocity increases, magnetic force also will increase. Okay, fine. So when it starts moving, magnetic force will be there. So since if it is moving like this, obviously this constant force must be greater than the magnetic force for some time. Okay, when this becomes equal, then velocity will become constant, right? So here we can find, suppose if the rod, if both of these forces, that is acceleration is equal to, suppose if it is moving with an acceleration, this acceleration is what? The F constant, external force, minus Fm divided by the mass of the rod, correct or what? Okay, F minus F, okay, F minus Fm divided by mass, that is the acceleration of the rod. Okay, now fine, A is equal to F minus, what is Fm? B square L square V divided by R divided by M. Okay, so acceleration is equal to Fr minus B square L square V divided by M into R. This is the acceleration. Clear or what? Okay, if this is moving, because if as long as this force is more than this one, there will be acceleration in this direction, velocity is changing. Okay, F net is equal to what? Ma. That is what. Now at terminal velocity, this F will become equal to Fm, that is F net is equal to 0. Okay, when what happens, this F net will become 0. Okay, so I think if you have understood this figure, shall I erase this? Okay, you might have completed drawing, right? So I am erasing this. Okay, so F net is equal to 0. If F net is 0, then what? Acceleration also will be 0. So I could write 0 is equal to Fr minus B square L square V. Right, this term will come to this side, that also will become 0. So B square L square V is equal to what? Fr, and we will be getting V is equal to what? Fr divided by B square L square. Clear or what? Okay, so which option is correct? Yes, option D is the correct answer. Clear? Okay, so hope you understood the question. Rod is there, this rod velocity is varying, some external constant force is acting. Okay, So that external constant force can be given also. Okay, if it is given, we can find it out. We can find the velocity. Okay, so external constant force is here, magnetic force is in this direction. They are asking the terminal velocity. Once these two forces are equal, then acceleration will be 0 and velocity will become constant. That velocity is what they are asking. Okay, so to NEET level, JEE mains level and all, these kind of questions, okay, we can expect. Fine. So practice well and try to take more number of problems and try to make your concepts very strong in this motional EMF concept. Okay students, so I am winding up this session. Okay, we'll meet you with a new concept in the next session. Thank you, goodbye, good luck.